Let's talk. I actually didn't think about literally any of what was going to happen after me clicking the start streaming button. So that's fun. Alrighty. It's 4 p.m. in Perth, and it must be 7 p.m. Eastern Standard. I've been thinking about like doing some streaming a little bit before, mainly because I think it's I'm interested in learning how to do Golang stuff better, because I'm a bit of an elbow. I think I'm a bit of an elbow software developer. I kind of brute force everything and just like smash all the keys until hopefully things work. And any opportunity to learn new stuff is obviously something that I'm really, really into. I guess the project that I wanted to talk about today is this thing called Hcltm. And I think there's probably like two things that, oh, that is really loud. Headphones went down. Oh, that works. You know, for those that are new to threat modeling, or those that maybe haven't used Terraform, it's like, I guess like all of these concepts can be a little bit confusing. Hcltm aims to be, and I can actually just show you because I wrote it in the README. It basically aims to be a, you know, like a means to document attributes of a threat model in a kind of pretty human readable way, but is also system digestible. And the intent from this actually came from when I was working at Hc Hcltm. The way that they actually worked developer wise was to have almost everything in GitHub. And I think obviously the context for Hc Hcltm, that makes sense. It's a company that's built on open source software. Open source software was living in you know, GitHub. So that kind of makes sense. And I guess, you know, we were trying to figure out, okay, so if all the developers are spending most of their time inside of GitHub, and obviously inside of their software development environments, what's the best way to try and make threat modeling close to, you know, close to the environment that they're working in? And that's kind of where this thing came out of. It was meant to be something that could easily be integrated into GitHub automation. And, you know, at the time, I am threat modeling castles. And at the time, Liam, I actually thought of you when I first did this little mock-up. I don't know if maybe I didn't mention it to you, but no, I totally did. Oh, I should tweet. I didn't retweet that I'm doing this. How do I do this on Twitter? Showtime. Come hang. Oh God. Yeah, actually, Liam, I was thinking of you when I mocked up this example. I also felt a little bit, I don't know, it was a little bit funny because honestly, threat modeling the Queen getting access to her crown was a bit funny. I probably just need a better use case for a castle. Oh no, no audio. Oh no. Wait, why do I have no audio? Let me see if I can figure that out. I just did like, I messaged, I messaged Sarah and I'm like, hey, can you still hear me? She's like, yeah. I'm like, oh, damn it. So either Twitch is having a hiccup, which I doubt, or Liam, you got to learn how to computer better. It is after 5 East Coast time, so who knows? Maybe you're a couple of beers in. Yeah, so the intent really was to try and figure out a standard format of documentation that would work, would work and align with how the software engineers were working, and would have some pretty simple workflows and automation into how they were managing files, which was all inside of GitHub. And then on top of that, there was a gentleman in the team called Kent, and Kent was doing all this awesome GitHub Actions workflow for like vulnerability tracking and issue tracking. And so he was building all this scripting into GitHub. And so that was kind of like, oh, well, this totally makes sense. Like this, we can have a simple format to define a threat model, and then we can have some automation in the GitHub Actions to turn these into dashboards and reports and stuff like that. And then obviously we can kind of have a centralized repository. Now, there's obviously lots and lots of different threat modeling tools out there. I know one that's kind of super cool, and it's different, but not exactly the same. I guess trying to be like leaning towards, kind of like a software engineering first method of threat modeling is this great thing called PyTM. So I don't know if folks have ever seen this, but it's this kind of awesome like threat modeling framework that's designed to effectively build out all this threat modeling fun stuff based on annotation, I believe, in source code. Now that I'm looking at this, I'm thinking maybe I'm confusing this with something else. No, I'm confusing this with something else. Oh, and that's so confusing. Okay, maybe I'm confusing this with something else, but that's okay. So, like getting started with Hc Hcltm, there's a couple of different ways to install it. The easiest way is if you just jump over to releases. You can come down to the release, and there is some downloadable assets here. So if you're on Linux or if you're using Darwin, you can kind of download these tar.gz files and then just drop the binary into a path. We also have the ability to install via, like with Docker. So if Docker is your jam, then you can run Docker. And I haven't published it yet, but I've also got a homebrew thing going as well. So that the next version of this, you'll be able to install using homebrew onto your machine, which is kind of nifty. And then basically, like the intent is, once you've got the utility in your path, you effectively get access to the Hcltm command, and this has a bunch of different obviously subcommands and subcommands and subcommands. The UI is built using the same library as Terraform and Bolt and all of that. And so if you use those sorts of tools, this is probably not going to be too different. But a real kind of a quick command would be to run HCLTM generate boilerplate. And what this does, this actually just kind of outputs, this outputs effectively like the whole specification of what the HCL files can actually look like. I'm not going to go into everything just at the moment, but I think it's kind of useful to know that obviously there's a whole bunch of stuff in here, a lot of it which is optional, and a lot of it which is actually required. But primarily, you basically, in a single HCL file, or you can obviously have multiple HCL files, you basically define a number of threat models, you give them each a name, you can optionally describe them, and then within each threat model, you can define different information assets and use cases and potential exclusions, third-party dependencies, and then you basically get down to the actual kind of threats themselves. And so within those threat model blocks, you can define a number of threat blocks. And each of these has things like, what's the description of this potential threat? You know, what does it impact? Are there any existing controls? If you're using the Stride threat modeling process, which not everyone does, you can obviously refer to those elements. You can then refer back to information assets that you've defined below. And you can also kind of define these proposed controls, which is things that don't exist yet. I'll touch on some of that stuff in the future. But what's kind of cool is that you can also, you know, from the generate command, you can also do this interactive mode. And basically, so if you just run HCLTM generate interactive, you get dropped into this this kind of interactive terminal thingo. It's using this library that I can't remember the name of the library, but it's actually kind of cool because you can do things like, you know, ask it for help, and you basically just answer these questions. So if we were gonna let's see, I know at a prior place that I used to work, a common interview question would be, how do you threat model a vending machine? And I reckon we should try and we'll threat model a vending machine. And so if people, I'm super interested, if people want to help out with some of these things, definitely pipe up for those that understand the threats to vending machines. So, vending machine. What is this question? At a high level, describe the scope. Oh, this is just like the threat model. So I think with the vending machine, it's like we have a vending machine in a public area with valuable goodies inside. We want to protect. Oh shit, what's happened? Oh no. With that's me not knowing how to wrap text when that thing takes the input. Vending machine. We want to protect the goodies inside the vending machine. You know, sometimes if you're doing threat models inside of an organization or something like that, you'll probably have existing documentation or wiki links or other places that you store information. So here you can provide those references, but I'm just going to click none. You might also have existing documents around the place, which makes sense. You might, you know, you might have like maybe someone's already captured a picture of what a vending machine looks like. I don't know. Like optional. This is basically like the only non-optional field. So you got to put your name in there. And then basically the system kind of gives you a bunch of different drop downs. Please provide us a few more attributes related to this initiative or project. Is this a newish initiative or a change to an existing one? Maybe let's say that, you know, maybe this is a new vending machine Does this initiative face the internet? Yes or no? So some of these high-level questions are meant to be, you know, over time, if you collect a whole bunch of different threat models, these attributes can help you define, you know, potential grouping and ways to look at, okay, so what are all the threat models associated with systems that we have published on the internet or not? Let's say that this vending machine is in fact on the internet to make things fun. How big is the initiative? Again, this is, you know, kind of for managing project size and stuff like that. I'm just going to leave it as undefined. What else? Would you like to add an information asset? So within each threat model, there's like a number of, I guess, information kind of assets. We can go through and actually add a whole bunch of information through, you know, in this part of the flow. For now though, I'm going to click no. I'll add a use case. Users who put money in the machine want a goodie. I'd like to add another use case. No. Would you like to add an exclusion? So one of the things with performing like a threat model is quite often it's handy to document things that are explicitly out of scope for the work that you're doing. You can obviously add them using the model. Here it's now starting to ask for actual threat scenarios. I am not going to add any for the moment. And then basically, like at the end of the interaction, it effectively dumps out the HCL output. So here you can kind of see like a representation of this model as defined by the specification, basically based on the information that we added. Now, the fact that it spits it out into standard out is kind of useless. And I think this command actually takes in some options that include out. So in theory, you can actually kind of add this to a, you can basically pipe the output of your threat model directly into a file. I'm just going to be real lazy and I'm going to copy it using my mouse. Copy. Vending machine. So now we have this file and it's pretty boring. One of the things that I got out of the box pretty early was the ability to be able to validate input files to make sure that they complied with the rules of the specification. I don't know why I can't tab complete that. But actually I should. I think that might be to do with the autocomplete. I'm going to add myself an issue. Let me see. This is me debugging on the fly. File names and running commands. Sweet. So basically the validate thing here is telling us that that HCL file is well formatted. If we go into here and we edit it and break it, potentially by like doing something like not closing that, if we run that command again, it'll actually it'll throw out errors, which is great. So we can see that our things are well formed. You know, if you're missing things, you'll notice that there's obviously other errors that are caught, which is lovely. But the stuff that I'm more interested in is the ability to start adding threats and also data flow diagrams. So if we go back, into the README, you'll notice there's a whole section on data flow diagrams. See below for data flow diagrams. This all goes down to the bottom, I believe. Data flow diagrams. And there's an example of which in TM2. So this logic here, like to define a data flow diagram, is it's yanked pretty much from this awesome open source threat modeling with Terraform thing that some of the product security folks at Marketer had put together. So Marketer is a marketing startup company out of the San Francisco Bay Area, and they released this tool called OTFP Terraform. Oh, it was a whole Terraform provider. So that basically allowed you inside of Terraform files, which are effectively like a particular format of, HCL, your ability to define a threat model, or at least like a data flow diagram. So they've got this example of a web application, and you can sort of see here they've defined this web app, and it, it has an ID, and it has this data storage, and it has flow, and it has these defined trust boundaries and processes and flows and things like that. Now, one of the things that the Marketer folks did was they also subsequently released like a GoDFD module for Go. And so this is great because obviously I could, HCLTM effectively pulls in and uses that capability to allow you to kind of define a data flow diagram inside of your threat model, which basically kind of allows you to define external elements and processes and data stores, and then put flows together between different entities, and it follows this format here. So if we pull up our vending machine, we can start to put here a data flow diagram. Now, there's an interesting, if you try to validate this now, you'll notice that because there's two data flow diagram blocks in that threat model, it's not going to work. So there are some logic rules kind of constraining what you can do. It's not necessarily that I thought these things out at all, but it was more about, it makes sense that maybe for a single threat model, maybe you only have one diagram. Although in saying that, quite often it's useful to define a threat model that has like a high level 0 context threat model picture, and then obviously have sub diagrams. So maybe there should be multiple data flow diagram blocks. Actually, that makes sense now that I'm thinking about it. I'm gonna put it in here. So in our vending machine, I wonder, I guess the first thing would be, does the vending machine even have a trust boundary? I guess there's all the stuff inside of the vending machine. I don't really know. Let's see. one of these in first. The reason that this has an empty parentheses is because in the HCL specification, these external elements are actually defined as a block. And the reason is because in an earlier version of this, the ability to kind of define the different trust boundaries inside of a threat model were actually defined inside of the elements, as opposed to kind of being like a parent level thing, the way that this trust zone browser includes a client inside of it. For those that are super interested, or if you ever want to play around with defining HCL inside of Go, it's kind of actually kind of cool. Like, I'm not too sure for those that have played around with Go before. They use these struct labels or struct tags to do things to allow you to kind of define, you know, this type information asset is, you know, the actual representation of a structure inside of memory, but then you can kind of use this kind of backtick format to also define what it would look like if it was going to be processed as HCL. So this is also the same thing. If you wanted to define things as they would also appear in JSON, you could also basically kind of use these here. But if we go down to like the definition of data flow diagrams, you can kind of see, you know, a data flow diagram includes an array of processes, an array of, or a slice, array/slice of external elements, data stores, flows, and trust zones. And then you'll notice that trust zones optionally also have, you know, links back to these processes. But if we look at, you know, like the data, effectively, you know, or an external element, it basically allows us to define a name for the external element and this kind of optional trust zone inside of it. The result of which obviously means that when you define these, you actually have to have an empty parentheses. I don't know if maybe there's some way to go around that. I don't know. There's something to play with. We then have the ability to define a bunch of processes. So this could be, you know, user gets, user pays finishing process vending machine delivers goods. I'm just totally making this up. What else should be there? Data store. Goodies themselves. Data store. Money reserves. Process. Data store. Missing something. I've also got things like external element, staff tops up vending machine. This in the threat model. Let's just double check. Cool. So that file is still okay. Now, what's funny is if we look at the DFD command, this is the thing that basically spits out the image of the DFD outside of like a kind of generated threat model file. So if we do out equals vending.png, vending. That not work. Oh, oops. Hc. You can see in this circumstance, like this data flow diagram is kind of crappy because we've got an external, we've got, oh, why is that triangle? B. Why? Don't know, that's not meant to look like that. Ah. That's better. Vending machine is topped up. Process. Money is removed. Oops. So a lot of the commands, when they generate output, there's an optional overwrite command. All right, so we can see now this diagram, which is also still kind of useless, is starting to have a whole bunch of different elements. We've got two kind of, I guess, entities slash users. We've got hungry customers and staff. We've got two kind of stores in the system. One is the goodies themselves, and the other one is kind of money. And then we've got a bunch of different processes. It's like, you know, vending machine delivers goods, vending machine is topped up with goods, money is removed, and a user pays the vending machine. Now, data flow diagrams without flows are kind of useless. And you can kind of see in this example, I mean, basically the flows kind of are effectively, you give them a label or a name. And the name doesn't necessarily have to be unique, but then the combination of from and to does have to be unique. So I think if we were going to add like a flow, money, from hungry customer to user pays vending machine. So if we do, now the good thing with a lot of the commands, you don't have to run the validate command again. So for instance, if we had botched this up, like we had misspelled customer, and we tried to do that, the validation routine will run and kind of throw out, hey, like this is not a valid connection, something is wrong here. But if we add that there, do that, and then open the picture again, we can start to see some data flows in this data flow diagram. Hungry customer is obviously putting money in vending machine. Now, if we tried to do the same flow again, I think this will, this will throw a duplicate flow error. I'm trying to think if change that to fake. I don't know if that's actually gonna, no. So obviously it'll try and do two arrows over the top of each other, so that doesn't work. But we can kind of see, like, you know, there's obviously this flow of money, hungry customer, user pays the vending machine, flow goes from this to money, to money reserves, float, goodies, vending machine delivers goods to good customer. All right, so we can start to see the picture is coming together a little bit. And we can also see that there's a bit of like a trust boundary happening here. I almost feel like trust zone. So if we kind of move those elements inside of this trust zone, you can start to see now this diagram has this, you know, this little dotted box around these elements. I also realized that it's like totally drink o'clock for Eastern states. I mean, it's drink o'clock in Perth as well. So I hope folks are enjoying cool beverages wherever they are, instead of sitting on a computer looking at Twitch. It's very weird. Oh, we can see here this vending machine delivers goods is on the outside of this trust zone, so that's probably something that is not correct. So let's move that inside here. A planet was taken. What's up? Good night. PM, good night. I'm good at computers, I swear. Sometimes. Actually, something else did look wonky with that. You notice that the goods here in this threat model doesn't, like the goodies themselves in this data store are not actually kind of given to the user properly. So there's another flow here. So this would be flow of goodies. Actually a different process, I think, in this one. If you think about it, there's also a process whereby validate payment. So if you think about it, before these two processes. The user pays the vending machine to the vending machine delivering goods. There's obviously there's a missing, you know, how does this thing know to kick off the action? So I feel like connecting user pays the vending machine process into the validate payment process, which then obviously kind of loops back to the vending machine delivers goods. Let's see. Vending machine to validate payment. We're all inside the vending machine. Actually, Philsy, you probably know about internet connected vending machines. That sounds like something you've probably hacked on before. I'm going to call that success because I don't actually know. From payment flow. Oops. Machine 2. That thing called vending machine delivers goods. Whoa. This diagram's now going off the screen. But you can sort of see here now, we've got... yeah, this is... I mean, we didn't even know what this vending machine is spitting out. Could be a beer vending machine. Which probably changes the threat model quite significantly compared to if it was a machine that spat out bubblegum. But we've got this hungry customer, they're paying money into this process, which is the user pays the vending machine. That obviously you know, updates this money reserves. It, you know, does a validation of payment. This validation payment thing probably has some interactions with a data store to determine what what's going on here. I might actually put that in there. Data store. Goody cost database. All right. I think that's everything. Vending machine delivers goods. Details. Validate. Hello. Validate payment. So that's the user side. I mean, I don't know. What am I missing something here? You're a user and you're going to go pay a vending machine. You're going to put money in the vending machine, and then the vending machine is going to do stuff, and then it's going to then give you what you're after. Or would you go lower in a threat model for a vending machine? Is this one of those tap and go vending machines? I mean, the threat model of starting to think about a tap and go vending machine actually is probably a real thing. I would hope whoever put those machines together. But that's the diagram so far. Now, that's all good for automatically generating a picture, and arguably this might be a pretty complicated way to draw a picture, and in particular because obviously some of these things are a little bit like, why is that line crossing that line when it could just go that way? Under the hood, this is just using graphiz .file templates. So in the middle, that Marketer DFD diagram library is effectively constructing, it's constructing dot files, and then I'm wrapping like a graphiz library in there, which is kind of like not super nice, but if it works, I think you can see that here. Yeah, it's literally like this. Inside of this function, which is the generate DFD PNG, this method basically, this function basically just takes like an output file path. It's obviously allocated against a particular threat model. It creates a temporary file. It then generates the dot file in that temp file, and this actually uses that Marketer DFD library. So this is kind of where most of the logic is in initialize the DFD, set up a bunch of zones, processes, external elements, and data stores, and then kind of iterate through the threat model of processes and elements and data stores and add them into the data flow diagram. Blah, 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 blah. Go through all the flows and add them into the thing as well. And then this logic here is basically what's used to construct a dot file. So this client thing here is based on the GoDFD library from Marketer, which is kind of cool. It creates this dot file, and then we further down, actually, what do we actually call this again? All right, so we output the dot file into memory from this temporary file. Oh, that's right, because this thing do that. DFD dot. Oh, the reason. So this was really frustrating. So one of the things on this Marketer library was the fact that when they were using it to create DFDs from Terraform files, it would always create. You needed to give it a file path, even though you don't even necessarily need to output anything to a file. Hence, in what I've done here is, I think when I call this, I actually give it a temporary file path. Yeah, it's a temporary file. I take the output, like the raw output of that file. I actually get rid of I just remove that temporary file, defer OS remove all temp file name. convert the output of that into a slice of bytes, and then I pass those bytes into this dot to PNG command. And then from here, I've basically wrapped the use of this kind of Go graphiz library, which doesn't have documentation, but it was pretty much, you know, like I think it's basically like a Golang wrapper around the graphiz, like either C calls, or it might actually call out to the operating system. I don't think it calls out to the operating system. I think it effectively uses the graphiz dynamic link libraries, I think. So anyway, the wonderful thing from this is that basically we pass in the raw graphiz data through, you know, this function call, which is to pass bytes. And then with that data, we then create a new graphiz thing, and then they've got like a render function, which will basically render a file, like it'll write a file out based on that graphiz dot information. So in here is like, for instance, if we wanted to change the format to a different image type right now, we're just using PNG, but in theory, we could output JPEG or SVG or dot files or whatever. And then, yeah, basically we output a DFD. Now, HCLTM, like when we first started working on it, the idea wasn't necessarily to make a shortcut for drawing diagrams, because again, like if we look at this diagram, it's not super pretty. The original specification basically had an allowance for a threat model. Where is it? A threat model to have like a diagram link. Because it was pretty common, at least at HashiCorp, that if diagrams were being created for a system, they'd be stored in like a Google Drive somewhere. And so this, for instance, would be just like a string pointing to that location. And it wasn't until later that I decided to like use the Marketer stuff to actually dynamically create DFDs. And what I haven't showed you yet though is the kind of dashboarding output, which was kind of like the primary intent behind the tool. And that is all executed inside of the dashboard command. And this is, it's not super complicated. It basically uses, like if we do the view command against that file, we basically see here this like terminal, I mean, it's like a terminal rendition. So Chumpy, is a pen tester using an O-day in a test in your threat model? I'm so oblivious. What was even going on today or yesterday with all the O-day talk on Twitter? I'm kind of happy being mostly oblivious. Oh shit, zero trust vulnerabilities. I wouldn't know the answer to that. Zero trust vulnerabilities sound pretty, I mean, do we just not trust anything? Maybe we don't trust. The real zero trust vulnerability is the one that we let into our heart. Wait a minute. If Snare's on here, I don't have a clock on my computer. But my understanding of math is, dude, it is late where you are. Why aren't you asleep? Unless someone's at, oh, well, I guess 1 a.m. What are you gonna do? Just hang out. Hang out. Thanks, man. Yeah, I mean, honestly, it was, the motivating thing was literally just a standard document template. And I think actually I put something in the README about like, hey, why don't you just like not use HCL? What did I write? It was an objection. I put objection handling in the README. Why not just document them in markdown? That's the correct format name, isn't it? They're markdown files. I think that's, I mean, he created the format, I think. But like, you know, YHCL, you know, you could use JSON and shit like that, or YAML if you absolutely hate yourself. I was just drinking the HCL Kool-Aid pretty hard at HashiCorp, and I was like, fuck, this stuff actually is not terrible to look at. I mean, it's not great to look at, but it's also not terrible to look at. Kind of like balked JSON, right? But yeah, so like the data flow diagrams, that's all good, but the actual idea was to create like a dashboard with all the threat models, and then in theory also start to create modular components that you could then import into your threat models. And then doing things like attribute-based control recommendations. So it could be, let me think of an example. It could be like, you know, it could be actually a really good example could be maybe you're working on a privileged access management solution, which is actually a zero trust product. You know, maybe you're working on a zero trust product like a privileged access management solution, and you've already built, you know, these shared libraries to do things like offset your crypto, you know, your crypto day zero challenges, not O-Day, but like, you know, those, what's that term for? It's like if you have to manage secrets in a secrets management solution, like you have to put a secret somewhere, and if you use a different system to store your secrets, well, then you have to authenticate to that system. And so there's kind of like this weird, it's a never ending like chain of at some point, someone's going to have a secret that they're responsible for, and they're probably going to screw it up. But the idea was that like if someone was building like a solution that was going to reuse some security controls, you could define those security controls in like a modular file. And then in a different threat model, you could import those controls as at least like a language reference, and then obviously be able to do some kind of mapping between those things. So I like the idea of having pretty flexible modular style control framework for threat modeling documentation. It doesn't necessarily help you do, you know, your job better. I mean, I'm sorry that everyone, like, you know, security people should be doing threat modeling better and not suck at doing threat modeling. And this isn't going to help you not suck at threat modeling, unfortunately. But it should, I don't know, it could offer an opportunity for, you know, maybe like a developer-friendly language file, I guess. Anyway, so like the output here is just like a, actually I don't know if there is a raw command. You can kind of see basically like the output of a particular model is this, this markdown format file, right? Which is super freaking boring. But the power comes from the ability to be able to generate a dashboard programmatically. So you could make like a thing, and you could do the overwrite and just put vending machine.hcl. And basically what this will do is, and you know, obviously if you point this to a folder with a bunch of different like HCL files, it'll start to construct them together. But if I open up I'm going to use my favorite markdown file viewing utility, which is VS Code. Oh, there's actually better ways to do it. It's got this little thing up here. You can start to construct like really simple little dashboards, and obviously each of the kind of the columns and stuff in the dashboard index, change that to whatever the hell you want. But the idea is that over time, as you start to perform more threat modeling, you start to have this centralized, I guess, repository of all of your threat models. And so you can kind of click on these and it gives you this like pretty output. And that's kind of like the start of what I wanted to talk about today. I'm gonna jump off because I have to go eat some delicious tacos. I'm probably gonna do more of these to try and, because there's actually like a whole bunch of other bits and pieces that it can do. And I've been working on some actual Terraform integration, which could be useful for those that like doing Terraform stuff. I'm sorry for those that do. But yeah, thanks. Thanks, nerds. Thanks for jumping on. Especially you, Snare, at almost 1 AM, you poor bastard. I hope you get some sleep. That sucks. Shit. But yeah, peace out, everyone. I hope for when your weekend comes. Yeah. I will. I mean, you know, like, man, this is pain you're going to understand. Like, I'm getting tacos in Perth, which kind of means even the best tacos in Perth are like worse than the worst tacos. You know, they're worse than the worst tacos in California. So you're at the pub. Woo! Awesome. Well, all right, hackers, everyone. Love you all. Have good weekends, and you know, I'll try and do more of these, maybe more in the future. Take it easy, everyone. Thanks for jumping on.